Hello, I am Edlabadkar from PVG's College of Engineering and Technology, Pune. Today we are going to see losses in centrifugal pumps. This topic is from Turbo Machines course, which is for 6th semester undergraduate engineering, that is TE Mechanical Engineering course. The main three types of losses are there in centrifugal pumps. First one is hydraulic loss, second one is mechanical loss, and third is the leakage losses. The hydraulic losses can be attributed to the loss of head due to friction in impeller, loss of head due to shock and eddies from inlet to exit of the impeller, and loss of head in guide vanes due to diffusion and casing. The impeller does work. It receives power from the motor shaft and transfers this power in the form of kinetic head being imparted to the fluid, which is in its close proximity. And as and when this fluid is churned and moves from inlet to outlet, there is friction between the impeller blades and the fluid. So because of this friction, there is some loss of energy, and that is to be called as loss of head due to friction in impeller. Even after very meticulous design and manufacturing of impeller blades, you would always have some loss of head due to shock and eddies at entry as well as exit of the impeller blade. And there is third one that we call loss of head in guide vanes. Guide vanes are the stationary vanes, right, which guides the fluid from exit of the impeller to the exit of the casing. So entry of the casing, I'm sorry. So the loss of head is there because of diffusion and casing. So as and when fluid, the kinetic head is converted into pressure head, there is the conversion is not 100%. So there are few losses because of bulk momentum transfer and friction between different laminae of the fluid. We call this as the loss of head in guide vanes due to diffusion and casing. Apart from impeller and casing, you would also have some hydraulic losses in suction as well as delivery pipe. And this suction, the major loss will be frictional loss in suction pipe as well as delivery pipe, and there will be some minor losses also, which could be termed as hydraulic losses, and it will be attributed to loss of head in bends, fittings, valves, etc. Next one is mechanical losses. These are the losses because of the friction between the different parts of the total setup, like you have got the impeller shaft which rotates between the bearings. So there is loss of energy because of friction at the bearings. Then there are also different parts which are mechanical in nature and which absorbs energy, which consumes energy. So these losses, they can be attributed as mechanical losses. And finally we have leakage losses. A certain amount of energy is always lost as some liquid leaks from high pressure side of pump to low pressure side of the pump. High pressure side of the pump will be exit of the impeller or inside the casing, right? Whereas the low pressure side of the pump will be eye of the impeller. So even after taking all precaution to make it leak proof, the fluid will have always tendency to move from high pressure region to low pressure region, and that attributes to some loss. So some fluid leaks past the glands and stuffing box, okay, and goes back to the suction side, and again is sucked and gets on board the impeller and gets the work done. So there is some recirculating fluid, right? So that attributes to what we call leakage losses. Incidentally, the difference between theoretical and actual discharge is called as the slip of the pump. So if these losses are to be talked in terms of efficiencies, then the hydraulic losses will lead to what we call it as the hydraulic efficiency. Does mean if there is no hydraulic loss, the hydraulic efficiency will be 100%. Higher the hydraulic losses, lower will be the hydraulic efficiency. Next comes the mechanical efficiency, which addresses to mechanical losses. Higher the mechanical losses, lower will be the mechanical efficiency. And third one is the leakage losses, which are addressed by the term volumetric efficiency. If the leakage losses are higher, volumetric efficiency decreases. If there is no leakage, volumetric efficiency will be 100%. If there are no mechanical losses,